beloved student or my beloved viewer. My name is Olenjolai&Nekinyi. I'm very happy to meet you today and to have you in this fantastic program. I'm from Tanzania, I'm a Tanzanian, and I would like just to say that here I am right now in order to transform your learning life in science and mathematics. So before even I give you some more details, I would like to take this opportunity to welcome you into one of our online schools that called Tanzania Online Secondary School in square bracket Olenjolai. Simultaneously, I would like to welcome you into one of our YouTube channels that called Tanzania Online or Level Secondary School in square bracket Olenjolai. Well, one of the questions which comes in the mind of the people who used to think differently, because I know that this program right now, maybe you're a student of ordinary secondary education, or maybe you're a parent, or you're a guardian, or you are a sponsor. Please pay attention for almost 5 minutes in this video, and then I believe that I will give you the quick overview of what are we doing and what is Tanzania Online Ordinary Secondary Education Schools in square bracket Olenjolai about. So I will just spend a few minutes to give you a brief explanations, but you can go in some. We have recorded a video for almost an hour to explain what are we doing and what we prospected to do in order to benefit and build the kingdoms of God in Tanzania. So firstly, the first thing which we like just to declare publicly, what are we doing? Why do we need Tanzania Online Ordinary Secondary School in bracket Olenjolai? Well, this institution, this online schools is actual, it's a solutions, providing solutions to hundreds of the problems faced by the ordinary secondary students on learning physics, chemistry, and basic mathematics for years. I am a product. I did my studies in Tanzania. So I experienced the problem when I was a student. I used to experience when I went into higher and higher academic level, I experienced the same problem. And there are so many different people, or teachers, other teachers, scientists, volunteers, entrepreneurs who have done and who have contributed a lot. But to my side also, God has given me a gift of teaching, and then He has given me an assignment to train and teach some students on how they can extract knowledge, wisdom, and understanding, and combine what they have extracted with the word of living God that written in the Holy Bible in order to solve real life problems. So our main objective in TOSO, okay, or TOSO, we call it TOSO, or Tanzania Online Ordinary Secondary School in square bracket Olenjolai, is to see our students when they are still in continuous studies or after they graduate, they are solving real life problems. So our strong desire, we don't want only to solve problems in class, but also like to take their knowledge and they will teach you to think differently, and will teach you how you can think beyond the teaching, the normal teaching that you used to get in private or secondary schools in order to solve real life problems. Because whenever you solve real life problems, then you become successful in life, because people they'll be paying you in order for you to solve their problems. So that is actually a brief introduction. So what are we doing? So this is the special online ordinary secondary schools that we are training only ordinary secondary students. Okay, and we have four departments. One department is called the Kingdoms of Heaven. Another department is called Departments of Basic Mathematics. We have departments of Physics. We have departments of Chemistry. Today we are in departments of Physics. In each department we have a number of the subjects that we are training or we are teaching by using different teaching methodologies, different teaching aids, different teaching style, and we really entertain you in order to enjoy. And believe me not, you will believe as long as you continue to join us that physics, chemistry, basic mathematics are the beautiful subjects, more than you think, more than even other subjects that you used to study, and they are not complex subjects. So that's the point that I would like to remind. So for example, in departments of physics, we are teaching 4 subjects: Physics Form 1, Physics Form 3, Physics Form 2, Physics, and Physics Form 4. So today, we want to teach you about Physics for the Form 4, right? That's why we say this content is for the pre-Form 4 or for students. Well, wonderful enough. I know you are the Form 4 students. You are preparing yourself to tackle the certificate secondary education examination in Tanzania. If you're in Kenya, you have your national exams. If you are watching this program from Nigeria, you have your own final exams in middle schools. If you are watching this program from UK, similarly, you will have exams ahead of you. But we'll be reducing the stresses, and we'll make sure that you confirm early as possible that that exams is your best friends and you're going to pass. But we don't want your visions to end on passing exams. We want you to think extraordinary, it means extra miles beyond the classroom instruction, beyond the certificates. That's our main objective. We know what we are telling you actually. It may be taking a number of years. For myself, I'm a product of what I'm telling you. I'm a product of a man who have extracted knowledge, wisdom, and understanding from the normal classrooms, and that is what I'm using right now in order to solve national problems. Remember that I'm a national teacher. I'm not maybe a teacher of a particular school, but again, I don't know everything about physics. I just small portions of physics. I always learn physics because I love. But that small portions that I know, I have a responsibility to teach others. So don't boast me that Olenjolai I know everything about physics. That is not true. I didn't say like that. So then we say that we have how many? We have so many topics. Of physics for the Form 4. I think that I mentioned in previous session, but I would like just to remind you. The number of them. So we have 7 topics, only 7 topics that you have to cover, but they are real intensive and they are new in the mind of the many students. So before I go into the overview, the quick overview, I have another important information. When you reported in any school, if you're watching me right now, you're a Form 4 students, or maybe you're Form 1 or Form 2 or Form 3, or even you're Standard 7 students, you're warmly welcome into TAYAI, because TAYAI is a good platform so that you can access its contents at any time and anywhere. So when you went to school in a particular schools, during your Form 1 or Form 2, or maybe you went for the vacations, when you come back, the first thing you used to do is registrations in order to give the notification that you are back and you are around, so they have to save you. Similarly, you can spend only a minute, just if less than 5 minutes to do registrations. And these registrations you are going to do is only one-time registration. You won't do several times, just to do once, then it's over. So because you want you to be a member, an active student, and serious students in TAYAI. So registrations in TAYAI. The first step, we ask you to open an email. We have 2 main types of emails, Yahoo or Gmail. Just to go online in Google, just ask that how can I open a Yahoo or a Gmail. The second step, you have to sign in YouTube by using your email, the one that you have opened. If you have an email, then you have to skip the first step. The third step, then you have to search this name, Tanzania Online O Level Circuit School in square bracket Olenjolai in YouTube platform. Then the fourth step, once you search it, you see the icon, the round button. So you see the round button like this one. Okay, so these round buttons for TAYAI, right? For TAYAI, you'll see the profiles of the national flag. So you'll see a national flag like this one, because it's the national flag here, and then you have to click it. So to click it means you take the mouse and then you click it. If you click it, then it will take you into the school where we have departments. And those departments, we put them in terms of the playlist. We have all the contents because this is not a physical school. Then when you are there, you will see a red buttons on your right-hand side like this one, or this side at the bottoms of the right-hand side, which is being subscribe. Click it once. When you click it, then it changes from subscribe into subscribing, and the color of the background also changes, and soon the icon of the bell appear beside it on the right-hand side. So click this icon supporting of the bell. So this is the bell. This is not all. Okay, icons, and then choose the options of all, then you are done. Why should you subscribe? We are going to have more than, because currently we are teaching 12 subjects in these programs. It's a work of 12 teachers, but I thank God by His own grace, He gave me that assignment to teach you all the 12 subjects without any kinds of too much hassles, and I will simplify your learning process more than you have ever expected. And I will convince you that science and mathematics are beautiful subjects, and you have to start love them if you hate it for some years or some months. So then this is just a sign of, oh, it's okay. So successful registered into also. So you have to start enjoying. Make sure that when you are, during the school times, when you finish your regular classes, make sure that you have an internet and you get into the Tohoso to check the updates, to check the new videos, because every day we are going to add at least one video in this platform until we finish this program. Wonderful enough. I think that you are overwhelmed. So I still have some other announcement, what I will give you later on. So I will give you as long as we continue our session. So let us come. So we are in chapter 1, it's called waves, and today in this session 3, I would like to teach our parameters of waves. Parameters of waves. Say with me, parameters of waves. But before I teach you today's concept, let me give you the quick review of what I taught you in session 2, right? So remember that, so in session 2, basically, I taught you about, before I go to the session 2, just to remind you, in physics we have 7 chapters or 7 topics. The first one is called waves. The second one is called electromagnetism. The third one is called radioactivity. The fourth one is called semionic emission. The fifth one is called electronics. The sixth one is called elemental astronomy. The seventh is called the geophysics. Okay? And we have some reference books that we've mentioned to you, and we did so many things, and we said that physics is the one of the branch of science, so we've been dealing with several things. Then we gave you the concept that you have to cover in waves. We defined the terminology, what the means of wave. But the last session, we ended on the real life examples of waves. Okay, real life examples of waves. That's what I want to just to repeat. So it means that what we taught you, the name of the session is titled as what? Real examples, if I'm not mistaken. Real examples, real life examples of waves. I don't want to teach you waves. I want you to see wave. Before I teach you waves, you are always surrounded with wave in your life, right? You have water waves, we have sound wave. You have been surrounded with music, that is all about wave. You have been surrounded by light, the sunlight, the sunlight. So the sunlight is also about wave. So it means that wave, this is a common phenomenon we used to experience in our daily life. Okay, so real life examples of waves. So we mentioned, if you do remember, the first one we say vibration of vibration of strings. And then I did the practice I demonstrated this by using a guitar. So example, you used to experience this in music. For example, if you play a music by using guitar or by using piano, all of them, that's the vibrations of strings. Then the second example, vibrations of springs. We have strings and strings. So vibrations of vibrations of spring. So vibrations of spring, it means that we say, if you do remember that the spring used to be like this one, but before compressions. But after compression, you find that the same spring now reduced in length. So this is after compression, this is with no compression. So in any case, in either case of this, right? In either case of this, we say that okay. So in either case of this one, then we produce oscillations. So another example, I didn't mention this, but this is very important. Simple pendulum, okay? During your Form 4, for the practical physics, it will teach you how you can do the experiment of the simple pendulum. So it means that the simple pendulums, you have a pendulum, and then you have a bob on it, then you can allow it, you can just pull it slightly, and then start oscillating. So that is the example 40 of wave. So another example, so this is the extra example, that the goodness of 40 of quick review. Ripples on the water surface, on the surfaces of water. So ripples, tell your neighbor, it's a time to enjoy the beauty of physics. Ripples on what? On the surface of water, on the surface of water. So we have ripples. And we have explained that, for example, if you go or you take some amount of water and put in a glass, and then you dip a stone, then you find that some waves start to develop. Okay, start to develop like this one when the stone is sinking. So that is wave. Those are the ripples on the surface of water. But again, she said that we have what is sound wave, human sound wave. Right now, you hear me because I'm using wave. So human sound wave is a real life example of wave. Human what is sound wave. So you hear me because I'm applying or I'm producing a wave. So when you hear my voice, that is a wave, which we call the mechanical waves we are going to discuss in the session 3. So I'm using the wave, that's why you hear me. So your ear can detect the waves. That's the point that I want to make. Then we give you an example that, for example, that we hear a horn, or for example, the sound of what? Sound of warning sounds of what? Of ambulance. Then we discuss this so many things. So today, let me take you into parameters of waves. Parameters of waves. Say with me, parameters of waves. Say it again. Parameters of waves. Parameters of waves. Say parameters of waves. Okay? So the fundamental question of this you can call just a question 1 to question 3.1 for the session 3. What is the meaning of parameters of waves? What does it mean? Before we discuss them, before we do any kinds of the manipulation, what do they mean? First of all, I like to learn by asking myself so many questions, or when I'm learning through the book, I ask the book so many questions. When I'm learning through online, I ask the online so many questions. When I learn through the internet, I used to ask the Google search so many questions. So my secret of learning, I think that what I'm teaching you, and even the thing which I know, I thank God because He taught me informally. So almost 70% of what I know, I learned them formally. It's almost 30% that I learned them informally. So I learned them formally. It means by I learned them through going to the class. Okay? So you say parameters. So parameters, ladies and gentlemen, parameters of waves are the physical quantities, which describe literally or numerically, they simply describe a lot of things, but the propagation or travel, because we say in a wave, there's also a process of travel, propagations of waves, from one point to another point. That's the meanings of the parameters. So these are the physical quantities. So when you hear about parameters, we taught you the meanings of physical quantities when we taught you introductions to, when we taught you measurement at the second topic of what? Second or third? I think the third topic of Form 1. So these are the physical quantities. So when you say the physical quantities, example of the physical quantity, we have two types of physical quantities. We have derived physical quantity and the scalar and what are fundamental physical quantities. Example of fundamental physical quantity, length. So we'll be talking about length, we'll be talking about time, but with regards of what? Of waves, right? So we'll be talking with these parameters, we'll be talking about parameter of the time, parameter of the distance, okay? And then parameter of what? Because we have mass, we won't talk about mass, but we have also some derived physical quantities such as velocity. Okay, but we'll talk about frequency, so those are the parameters that we are talking about. Okay? Again, after defining, we say that in physics, there are basically parameters This we call them basic. It means if you advance on learning wave, you find some other non-basic parameters. So basic parameters, and you encounter these parameters in any types of the wave. Okay, there are basic parameters which describe what the propagation of a wave through a medium, through a particular medium, for example matter, or through vacuum. Vacuum is no medium, so in air. Okay, so in physics you say there are some basic parameters which describe the propagations of the wave through a medium or a vacuum. So these parameters are, let me mention and then I'll explain each of them. These parameters are, the first parameter is called the amplitude. It's called the amplitude. And you'll find that, you'll see that we notate use A. The second parameter is called the period. This is capital T. The third parameter, which we are going to discuss, is called the wavelength, which symbol is lambda. Then the fourth parameter, we call it velocity or speed. Okay? Then this is V or C, depends whether it is electromagnetic waves or what. Whether it's electromagnetic waves or mechanical waves. Okay? Copy these steps of you to be registered permanently in Tanzania, Tanzania Online Ordinary Secondary School in square bracket Olenjolai. So you can pause the video and copy all of those steps. And thank you for your cooperation, and thank you for being a part of, for being our students and giving us a chance to teach you. So, in order to understand also these parameters, we have to represent a wave graphically. So when you present a wave graphically, then we'll see this parameter, and also after present the wave graphically, we are going also to we are going to have, but they have 5 frequency. Number 5 is frequency. So another basic parameter of the wave, whether it's electromagnetic waves or mechanical waves, we need also to know about frequency in advance. So when you sketch the graph, we have also some other two shapes of the waves, of that waves. Okay? So ladies and gentlemen, in order for me to teach you and in order for you to understand these 5 basic parameters of waves and remember what I have taught you for the rest of your life, let me represent a wave in the graph. After presenting the wave in the graph, I will show you all of these 5 parameters, and then we are going to discuss each of them. Are you ready for that? In case you have any questions, don't hesitate to ask in the comment section. Again, another thing that which we would like to tell you in advance, tell us in the comment section so you're enjoying this material from which secondary school, from which country, from which city, from which what. So tell us from which village, tell us. And you have to give us comments if you understand us or you don't understand us, so we can improve our way of teaching. So ladies and gentlemen, let me teach you about graphical representation. Because when we teach you graphical representation, just like you saw practically, those 5 basic wave parameters. So graphical representation of 40 of wave. Graphical representation of a wave. Okay, of a wave. Graphical representation of a wave. So a wave can be represented graphically as what? So a wave can be a Enjoy the beauty of physics. Tell your neighbor that physics is beautiful. A wave can be represented on the graph as a function of displacement, which is y, displacement against time, which is t, against the time. So a wave can be represented on the graph, okay, okay, as a function of the displacement against time. So I think that the best way, let me just present the wave there. Displacement y or displacement x, but let us y, just to simplify the concept. So let me represent the waves on the positive x-axis. Okay, positive x-axis. Want to have a clear. Okay, so this is the x-axis, which is x time. So I can sketch this. So set the 2. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So here we can have our dotted line, dotted lines. These dotted lines will show the crest of the wave. Then here also we can have our dotted line. This is the maximum displacement of the wave. Okay. So this is time axis, t in second. Okay. And then this is rest position 0. So this is the starting of the wave. So it will be propagated like this. And then it will be propagated like this. So that is the figure for, so remember that this is displacement y, and that's the time. So this is 0. Then from here to here it is 280 degrees, and from here to here it is 180, so it will be 360 degrees. From here to here it is 180, so you have to add it to make it 450. Cos 0, then so we have here 0, then 14, then we have 5. So 540 degrees. Okay? So these are in terms of 40 of degrees. You have to sketch to draw well these cycles, because this in physics and also mathematics we call them cycles. Okay? So you have to draw them well as we can. So this is, we call it figure 3.21. So this is the simple graphical representations of 40 of a wave. Simple graphical representation of a wave. Let me represent now a wave with its 30. It is basically 4 parameters. Okay, it's 4 basic parameters. So I'm going to sketch the same figure, but now I'm going to add more information. So this is the wave, remember that, because you might be wondering what is this. So this is what you call a wave. It can be either mechanical wave or electromagnetic wave. And this is the time axis, this is the displacement. means that the vertical displacement of the wave. So the wave is always sinusoidal or cosinusoidal. Okay? So I think that I finished it all, sketch. Now, ladies and gentlemen, get prepared to enjoy the beauty of physics. So now let us draw or represent the wave graphically again, but we add some information. This is y-axis in xy plane, but this y-axis in a wave we call it displacement. And then the symbol, the common symbol is what? Is y. Okay? So common symbol is y. And then I think the best thing is, let me present on the positive x-axis. Okay? So when present this wave on the x positive axis, so this is the one of the axis. Okay? So this is y-axis in xy plane, but this y-axis is called the displacement. Displacement y. Then next we have this. Primary level opacity. I think the best way, let me draw here. Okay. Oh, so it's real shaking. Let me. So is this a straight line? Yeah. Believe it. Okay. So again, have some few measurements. So this is the 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Then we have what? Again, 1, 2, 3, 4. Then 1, 2, 3, 4. So this is what? Usually it is x-axis, but this is time axis, which is symbol t. Okay? And then here we have time axis. And simply again we can have this one. So again we need to have the limit or the boundaries of this wave. So we have this 1, 2, 3, 4, 5, 6, 7, 8. Okay? So again here we have 1, 2, 3, 4, 5, 6, 7, 8. So now we have this one. So please, physics is experimental subject. And even in the next session, I ask you to come, or if you can, if you love, I know you love physics, for the students and teachers and trainers who love physics, basically used to have a special grace to indicate like a physicist, means to look like a physicist, but real, you imitate your life style and also your thinking. So in the next session, I will come with a special overcoat that will be used in physics lab. It's not mandatory, but when you get into the college, you find that the overcoat is mandatory, especially in engineering colleges. Okay? So this is 0. So 0, suppose that this is 90 degrees, because we want to prevent the, so it is time, but we have angles also. This is 180 degrees, this is 270 degrees, this is 360 degrees, so etc., etc. On this side, if you could prevent the wave from this side, you have negative 90 degrees. So in other words, negative 90, we can present as negative pi over 2. Here it is pi over 2 positive. This is pi, okay? This is what? 3 pi over 2, and this is 2 pi. Pi is equal to, remember that, pi in physics is equal to 100. So pi radians. When we say pi radians means 22 over 7 radian, okay? This is equal to the degree of 180. So next, now we can sketch our wave, okay? So we can sketch our wave profile. This is our wave, okay? So it cuts here, then it comes and touches this, then it goes up, then it touches there, okay? So in this wave, we can now extract some more information. This is half cycle, and this is another half cycle. So first of all, this is the wave. Okay, and this one now, and this one, we call it also, that's the wave. That's line, it's the wave. And this we call it trough, no, crest. I will tell you what the means of crest. But crest is outside what? Outside trough. Outside the cycle. And this one, in physics, in wave we call it trough. Say trough. This is also another parameter that we have discussed because we find it in every wave. The first one, crest, say crest. The second one is what? Trough. So all the bottom cycles are trough. But again, we say that, listen careful. So we say that we can have these are the 4 parameters as I gave you a promise that we can show them in our wave profile. So let me sketch like this one. What can you see as a distance between this line and this one? So that this distance has a special name in terms of distance. So the distance in wave, we don't call it distance, but we call it wavelength. So the first parameter is wavelength, which we said its symbol is what? Lambda. But again, we have another physical parameter, which is called what? Which is called the amplitude. Okay, amplitude. So we can sketch it here. This is our amplitude. This is our what? Or amplitude. So mean that you can adjust the graph a little bit. But that's how. So the amplitude divide the amplitude in crest, divide the crest into 2 equal parts. So this is just minor errors in sketching. So, ladies and gentlemen, in the graphical representation of the wave, this is what we call amplitude. Say with me, amplitude. Again, say amplitude. So this is what we call amplitude. Okay? And then we have another terminology which is called period. Say period. So period, it's a time taken to complete one cycle. So we'll define it soon. Okay? So we have this, we have this. So the time taken for a wave to move from here, towards this point, for the wave to move in this way, up this point, we call it in wave or in physics period, which is symbol is what? Is t. But again, so you have what velocity we cannot show, our frequency is just the same. But again, we have something else here that also the distance, the distance between these intervals, okay? The distance between these intervals are what? So the distance between these intervals, the distance here, is called the 1 cycle. So this is 1 cycle, not cycle that we taught you in mathematics or Form 3. This is a little bit different cycle because the radius of the cycle is constant, but the radius of this cycle is not constant. So I'm trying to write a good spelling so I cannot confuse you. So this is 1 cycle. Okay, 1 cycle. So cycle of this is time. Why do we call it a cycle? Because if, for example, we take this crest and combine with the trough here, so we are going to have a cycle which does not have constant radius from the center. So if this is, suppose that this is what? This is crest and this is what? Trough. So you see the distance, if this is the center, the distance from here to here is not equal to the distance from here to here, right? So all of these shapes, we call them in physics or in mathematics, cycle. So this is 1 cycle. So 1 cycle has a degree of 360. So ladies and gentlemen, this is very important figure for any physicist of ordinary secondary education. So this is figure 3.2. Wonderful. Remember again, physics is a practical subject, so we like to present informations in tables, because tables are table results, are the tables of results of experiment. We also like to present the informations by using graphs. So you should love to draw graphs or to sketch graphs, because is all about physics. Okay, so we'll be sketching, especially in wave, we'll be sketching when we're teaching about compressions and refractions. So we'll demonstrate the concept by using graphs. Okay, so the next stage now, we have this fantastic. My dear students, even if you forget everything tonight in this session, please remember this graph, because it will help you to simplify and to understand so many concepts about wave. So now let us see the parameters of the wave. Okay? So parameters of waves. So we have mentioned 5, but in figure 3.2, we have also other 2 parameters that we have to start with. And this, the first parameter or the first shape is called the crest, right? So we call the crest. Say crest. Say with me crest. Say with me crest. So we have a first phenomenon called the crest. Ladies and gentlemen, pause the video and ask yourself, what is crest? What is crest in wave? Okay? Ask yourself this fantastic question. What is crest? Okay? So when you ask yourself, you say that the crest is the maximum positive displacement of the particle from its rest position. Crest. So pause the video, ask yourself these questions, try to answer that questions on the piece of paper, and then you come and check the solution. Crest is a maximum, say maximum positive, say with me, maximum positive displacement. Okay, displacement. We taught you the meanings of displacement in motion and the difference between displacement and watching and the distance. Is a maximum positive displacement of a particle, of a wave particle from its resting position. From its resting position. So crest is the maximum positive displacement. So if we see the word positive, always you have to expect to have negative, right? So crest is a positive maximum displacement of the wave particle from its resting position. Where are the resting position? This is resting position of the wave. So you have to label resting position of the wave particle. what is passing here? This is not a line, this is a particle. So it means that a crest is a maximum displacement all of this way. So crest is all of this way, all of this way, all of this way to here. That's why we call it, this is positive because this is 0. So this is positive displacement, and here we have negative displacement. So this is the line that it means separate the positive displacements and negative displacement. So that's why we say this is a crest. Against, if we could have this wave continue, continue and descend, we have another crest, we have another crest, we have another. So you can have infinite number of crests in a single wave particle because the wave particle is just moving, dynamically. So this is the meaning of crest. The second terminology which I'm interested in is the word we call it trough. Say trough. Okay? So crest is singular, but if you have more than one, we call them crestes. Trough, say trough. So the next question, fundamental question of teacher Olenjolai is, what is trough? What is trough? Okay? So simply we say that trough has a close meaning, but a little bit different, but a minor difference from the crest. So say trough is a maximum for negative, is a maximum negative displacement. Is a maximum negative displacement of a wave particle. Of a wave particle. A wave particle from what? From its resting position. So trough, it's a maximum negative displacement of a wave particle. For example, my sound. Now, when you hear the sound from my mouth or from my lips, then this is a mechanical wave. So I told that this is the wave. So it means that there is a vibrations and there's a compression or refractions of the air in between me and you, or in between me and the camera, video camera recording this program right now. So that compressions and refractions, it's sinusoidal. So the waves is just coming this way. So if you draw the waves now from my sound waves, you will see this profile. So this we call it wave figure 3.2, we call it wave profile. So wave profile. So it means that a wave profile has crest, trough, crest, trough, crest, trough, crest, trough. Crest is what? Maximum positive displacement. Trough is what? Maximum negative displacement. So that's why that we say this is the trough. So if the waves continue to here, you have another trough. Then you have another crest. Then you have another trough. Then you have another crest. Then you have another trough. Then you have another crest. Then you have another trough. You see? You have another trough. Then you have another crest. So that is how the beauty of waves and the waves used to move or to transfer energy. Because remember the definitions of the wave. I told you that wave is a disturbance that travels through either a medium or vacuum without any transfer of its medium itself. A wave is a disturbance in a medium that carries energy without a net movement of the particles. A wave is a propagating dynamics disturbance in bracket change from equilibrium of one or more quantity from one location to another location. Wonderful. So we have to still keep the definitions of the wave throughout our learning process. Okay, so it means that a thought of a wave particle from its resting position. Okay. So from this session 3, I believe that you see the beauty of wave and the beauty of physics. Okay. So I believe that from now onwards, when I mention trough or crest, you understand what I mean. The third terminology or the third parameter, we call it wavelength. Ladies and gentlemen, say wavelength. Wavelength. wavelengths, if you check this word, it's a combination of 40 of two words, wave and the length. That's the special revelation. Wavelengths, okay? Wavelengths. Wavelengths, okay, forgot to hear. That's what I was checking. Wavelengths. Yeah, wavelengths. So you have TH. Yes, wavelengths. Say wavelengths. That's the same vocabulary. I'm not arranging them in terms of simplicity or whatever. Just arrange them the way I feel from my heart. So wavelengths, say wavelengths. So simply, before I define the meanings of wavelengths, you should have something in your mind. I know this is the new term because we have never taught you in entire physics of Form 1 until the physics of Form 4 about wavelengths. So we're introducing to you okay, so we have a very fantastic terminology there that's called wavelengths. So let us focus on that, the knowledge of the wavelengths. Okay, so as I say that this the combinations, wavelengths is made by the two words wave. So before even define, you say that, let me just write this for you, for your advantage. It's a revelation that myself I got today. I've been learning wavelengths for more than 12 years, but I've never discovered that this word wavelengths is the combination of the two words. So, okay, wavelengths is the combination of two words. So if you break down these words of wavelengths, then you find you get two words. The first one is wave, and the second word is length. So simply wavelengths, it's a length of 40 of a wave. It's a wavelength of 40 of a wave. So right now, we go into the fundamental question that what is wavelengths? What is wavelengths? That's the question that you have in your mind. So it's a wavelength in simple language. Wavelength is a distance between two successive crests or troughs. So successful cresty or successful troughs. So that's the meaning of wavelengths. Wavelengths is the distance. It's not the story. It's a distance between two successful cresty or troughs. Are the meanings of wavelengths. So simply the distance from here to here. The wavelengths also corresponding to 2 pi or 300, 260. So wavelengths, the distance between successful cresty or successful troughs. Successful cresty or successful troughs of 40 of the wave. So we say that in physics, okay, in wave or in science, let's say the wavelength or length of the wave, the wavelength is denoted as lambda. So this is called it lambda. Lambda, so this is the one with the Greek symbol, which is this one. Okay. So that's all. So I don't want to grab the figure 3.2 because we still need it. Okay? Then again, because this is the one of the physical quantity, which is very important to say that the SL unit of wavelengths is meter. So SL unit of wavelengths is what? is meter. However, that wavelengths of electromagnetic spectrums can be expressed in angstroms or in a nanometer. But the SI unity is what is meter. But for in case of electromagnetic spectrums, we have also for the long wave, for the longer wave, or for the longest wave, we have angstrom as a unit, and also we have nanometer. That's all about wavelengths. So the first terminology which we have in the graphical representations of 40 of the wave is amplitude. Amplitude. Say amplitude. 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 So amplitude is either its symbol is A. So it's only amplitude. Where the amplitude is the amplitude. So what is an amplitude? This is the new term for the Form 4 students. So what is amplitude? What is amplitude? Okay? So simply say the amplitude, this is a maximum displacement of 40 of the medium particle from resting mean position. So simply in physics or in wave, we say that amplitude is the maximum, so is the maximum displacement, the maximum displacement of what? Of the wave particle, from its resting, or we call it mean, or we call it equilibrium position. So say amplitude is a maximum displacement of the wave particle from its resting position. So amplitude is the maximum displacement, so it has a particular directions. That's why we call it displacement, it's not a distance. So amplitude is simply the distance from this point to this point. So this is the maximum displacement of the wave particle. We don't have any maximum displacement. Here we have also a displacement, but it's not maximum. Here we have also another displacement, but it's not maximum. Here we have another displacement, but every point we have a displacement, but not maximum. On this side we have a point, but it's not maximum. This is the displacement, but non-maximum displacement, non-maximum displacement. So the only maximum displacement is what we call it amplitude in wave. Right? So in physics, it is, so I say that amplitude in wave equation laydowns, we'll teach you when you get it from 5 or ordinary diploma. Amplitude is donated, so we're talking about notations as what? As capital A. That's why I've written amplitude in bracket A. The SI unit of what? Of amplitude is meter. At the SI unit. However, that can be measured in other physical, in other dimension, or in other units. Then, ladies and gentlemen, the next terminology, this is the fifth terminology we have to now learn about period. Possibly you have heard about this. I think that this is the one of among the first physical quantities that you have learned throughout your life. Again, I want to tell you that in case you feel from your heart that you want to offer God your free will thanksgiving for this program, don't hesitate to do that. You can send your free will thanksgiving offering of any amount through this telephone number 0759745331. And then to be received, you say hands of thanksgiving, and may God bless you abundantly. And believe me, that is going to be used effectively to pay for the running cost of these programs. I told you that we're expecting to have more than 600 videos of training for the 12 ordinary secondary subjects, 12 subjects, 8 in physics and chemistry, and 4 in basic mathematics. And it's not the end, because we still know a lot in ordinary education. So some of the other subjects might be along the way. For example, additional mathematics might be along the way, and also the revelations in biology might be along the way. So you have to keep on praying, because God is faithful. So in case you want to do the bank transaction, your parents want just to make sure that those 600 videos, to record one video is very expensive, I tell you. Just to produce one video, it's expensive. So can you imagine 400 videos? But God is a sponsor of this program. So we don't put the limit for you, but it's you have to offer from your heart, right? We don't. It's not mandatory. It's not compulsory, and we don't need just an aid. We need offerings, because offerings will give you blessings on what you are paying for. Okay. So the fifth terminology is period. Say period. So period, you heard it as one of the first fundamental physical quantity, but there you heard period in terms of time. Time is a general time, or general sessions of the, or maybe general sessions, or it's a part of the day, or part of the hour, etc. But period now, this is the special terminology of the time. So the fundamental question we have, what is period? Ladies and gentlemen, what is period? Okay, so we say that period is a time. So period is in regards to waveform, wherever you find the term period. So is the time taken in case of wavelet now, the time taken by a wave particle to complete one cycle. So this is a very special time that a wave particle, because we have different wave particles in different occasions or in different systems, so it depends. The periods of sound wave might be, the periods of my sound wave might be different from the period of your sound wave, right? That is. So the period is a time taken by a wave particle to complete one cycle, not cycle, one cycle. So the period is the time taken by this wave particle that was in the resting position, just to travel, okay? So to transfer energy to here, to transfer energy, it goes, so it's taking time up to here. So when it reaches here, now it has completed one cycle, and also it has spent a time, we call it a period. Why do you call it a period? Because periods, it has a tendency of repeating after a particular interval. This time, for example, if it is 20 seconds, so another wave particle, or the same wave particle, when it's continuing to travel in one cycle, also is going to spend 20 cycles. When we make against another cycle, it's going to spend, or it's going to take 20 seconds. Against, so it's just a matter of repeating the wave pass. So that's the period. So the periods, it's donated, so in physics you say that this is denoted as what? As capital T. So donated as capital T, capital T. So what's the SI unit? SI unit of period. So SI unit of period, which is T. SI unit of T is what? Is seconds. Second. That is SI unit of period. Okay. So again, another terminology which is we didn't discuss yet is the closest friends of this, of period, and this is what we call the frequency. And this we notate with small letter f. So it means frequency. Say frequency. In English, we know the meanings of frequency, that it means just doing something often, okay, several times. So I did these things maybe 4 times, so I do it frequently. I do these things frequently, it means I do it every day, or maybe after a particular interval. But in wave also we have this physical parameter. We have this physical quantity, which is the wave parameter. And I would like to challenge you and ask you this question. And you have to ask yourself, what is frequency? What is frequency? Okay? So frequency is the number. Frequency is the number, not politics, of cycles. The number of cycles completed So the number of cycles completed by the wave particle, in 1 second. In 1 second. That means of frequency. Frequency is the number of cycles completed by the wave particle in 1 second. What does it mean? So listen carefully. Let me explain here. For example, suppose that we have a wave profile of displacement y against the time, right? And then just this is the sketch. I want to explain to you the means of frequency. This is the rest positions, because I know many students, they used to hate physics because they used to believe that it's difficult. Physics is not difficult. So for instance, that I have a wave particle that traveling sinusoidally. So this we call this sinusoidal up to here. Okay? So up to here. So it means that this is point A, or this is point O to point A. Okay? So how many cycles do we have? How many half cycles do I have? I have 1, 2, 3, 4, 5 half cycles. How many crests do I have? I have 1, 2, 3. How many troughs do I have? I have 1, 2, 1. Then how many cycles do I have? A cycle is formed by the the cycle is formed by a crest and the trough. So this the crest and trough, we form what? We form the cycle. So that's the cycle. So this cycle is what we call the period. Alright? That's what we call the wave period. So now, so this is the first cycle. Then if we come to here, we get the second cycle. So this is the first cycle. This is the second cycle. Okay, second cycle. And then suppose that point A is somewhere else there. This is point A. So it means we can have another cycle. So again, this is the third cycle. So we have first cycle, second cycle, third cycle. How many number of cycles do we have in this trajectory of the wave? 3, right? So we have what? 3 cycles. So if a wave particle completes 3 cycles in 1 second, this will make what? Frequency. So the frequency for this wave particle, it is 3 cycles per second, which we call it 3 per second. And this because of the hammer of hertz, so it's called the frequency of that wave is 3 hertz. It's not difficult. You have just to watch this video several times until these concepts build in your mind. Okay? So that's the meanings of frequency. Because I don't want you to claim physics. I don't want you to claim chemistry. I don't want you to claim best mathematics. First of all, I don't know how to claim. I failed for the rest of my life because I've been learning or in process of learning for more than 20 years. I failed really to claim. So I used to struggle much to understand. And that's what I can teach you, right? So this is the level, this is the understanding. Just watch this, you listen carefully, concentrate, you understand what the means of the frequency. So it means that before even thinking about notation, according to that definition, we say that frequency simply, which is F, this is equal to what? Number of cycles power t in 1 second. That is, so number of cycles in 1 second. So we say that frequency is denoted as what? As F. So denoted as what? As F. Then the SI unit of frequency is per second or hertz. Hertz, this is a name of the person who discovered frequency. It's the name of the physicist. So this is the name of what? Of the physicist. So that's why we say that in that experiments we had 3 cycles, or that demonstration 3 cycles, that mean that the wave particle completed 3 cycles in 1 second, right? So if you completed 3 cycles in 1 second, mean that is 3 per second. Per second means 1 per second, right? So then this is equal to 3 what? 3 hertz. So that's the example, right? So this is a demonstration, because students used to claim frequency, they claim they don't understand practically what does it mean. Again, we say that we have a good news, okay? And the good news that we have also the relationship between what? These are the deviations of between frequency and what? And period. So there's a relationship, mathematical relationship between frequency and what? And period. How do they relate? Listen carefully. What is period? It's a time taken to complete 1 cycle. That means of period. Period is time taken to complete 1 cycle. So if that's the case, you say that frequency, for example, if a wave particle completes 1 cycle in a second, it means, because remember that period, it's a time taken from here to here. So you have only 1 period. So simply say that, in other words, if we define in terms of the periods, because this is the repetition, frequency is equal to 1 cycle of what? Of a period t. Because remember that we say frequency is equal to number of cycles over per seconds. Or we say that number of cycles generally now. This is general. So generally, we say that frequency is equal to 1 cycle over periods. So this is it is 1 over period. Students used to claim. They used to claim, and teachers also used to accompany them just to claim that frequency is equal to 1 over periods, but they don't know where we get this. This means that frequency is equal to 1 cycle completed by the wave particle in 1 second. So with this one, again, so we can express period in terms of frequency. So it means that we can multiply by t both sides. So if we say that frequency is equal to 1 over period, we want to make period the subject. So you have to multiply by period both sides. So you find period times frequency is equal to 1. So to make period the subject, we have to divide by frequency. So in other words, also period is equal to 1 over frequency. 1 over frequency. So the unit of period still what is seconds. Okay. So let me end this session by teaching you the last basic wave parameter, which we call the velocity. And then so I will end this session. Okay, we end this session. So we have the 7th terminology. We call it wave velocity. Okay, wave velocity. Wave velocity. Or simply just we call it velocity. These are the 2 words, so you can call it velocity. So generally, we notate this as V, but later on we'll change. When we'll be dealing with electromagnetic, with the letter, the notation change from V to C, lowercase c. So we have the mental question. What is wave velocity? Okay, what is wave velocity? Just like in mechanics, we told you about the velocity of the car, the velocity of the train, the velocity of the truck. So what is the velocity? What is wave velocity? So simply say that this is a rate of what? Rate of change. So velocity is a rate at which the wave is moving. Is a rate at at which the wave particle is moving either in a medium, or in vacuum. That is. So what is wave velocity? Is a rate at which, so this is the rate at which the wave particle is moving either in a medium or a vacuum. So it's a rate. So rate means something over time, right? So mathematically, we can show that, or we see that the velocity, the wave, velocity is equal to what? Distance of what? Over time. So even wave velocity also is the distance traveled by a wave particle over time. Okay, so if that's the case now, let me give the homework for it is enough. It's enough. My Father in heaven is just telling me that Olenjolai, it is enough. You can overdose my students. So it's enough. Keep the rest for the next sessions, which will be session 4, which have you should not miss. So it's a time for the homework to test your understanding. Homework, and this is homework 3. Homework 3. Okay? And this is example 1. Okay? So the example 1 means that this is, okay? According to what I've told you, so, okay? So it says that they use the formula of the relationship. Okay? They use the formula of the relationship. Okay, relationship of what? Of wavelengths, which is lambda, then frequency, which is f, and what? And velocity. So they use the formula of the velocity, velocity of wave as functions of what? Of wavelengths, frequency, and the as functions of wavelengths and the frequency. As functions of wavelengths and the frequency. That's the question. For example, that formula, or for example, let me just give you an example of what does it mean. Okay? A simple example, you remember that we taught you pressure. And then we said pressure is equal to force over area. Right? So this is the dependent quantity. These are two independent quantities. They don't depend on the temperature. Right? So it means that in this one, we say pressure is a function. Pressure is a function. It means pressure depends on what? It's a function of force and what? And the cross-sectional area where it acts. So that's what it means. So we have deduced the formula of the velocity of wave as a function of wavelengths and the frequency. So there is no distance. So that is the full stop. Please do it and submit your homework in the comment sections there. So before you end this session, when God gave me an idea of founding this online schools that called Tanzania online ordinary secondary school, then he kept on giving me different revelations, okay, in order to help the students. And one of the area of interest is the library. So God has given me an assignment to establish Tanzania Online Ordinary Library, where that we can provide, or we can distribute, we can collect books and put in our libraries, and then students can order them, and we can send to them in any region, in any schools of Tanzania, by using the public buses, or by using different methodologies of transferring the packages. So I'd like just to give you, or to share with you, or to show you some examples of the materials that we have in Tanzania Online Ordinary Library. One of the essential material is the syllabus, right? So the syllabus like this is called the physics syllabus for ordinary secondary education, Form 5, Form 1, so Form 4. If you have this book or a copy of this book, you are going to use it, and then because you're a Form 4 students, then you leave it to your young brothers and young sisters. They have to use this book from Form 1, Form 2, Form 3, and Form 4. It's very important. In everything I'm going to teach, I should also make sure that I align proportionally to the contents of this syllabus. So you can order a copy of this book. In case you want to know the price, just go to the descriptions of this video. Then you'll see the video that will give you. You'll see the link that will take you into the video for the library, which will give you information on the library. The second weapon, so the second material, is one of the reference book. I have mentioned more than 5 reference books, reference materials that you can use on learning physics for 4. So this is the one of them, that the physics Form 3 and 2 and 4 students book. It has been prepared by Tanzania Institute of Education. You can order also this book. We have so many of these books. You can order. It is cheap. You can order with this syllabus, so it becomes kind of the small package. But again, we are not satisfied. We are not satisfied to teach you about concepts and do questions in the book. It's also better if we prepare you to tackle the next exams, which is ahead of you. That a few months later, you are going to be a candidate. You are going to sit for that exams, and we want you to succeed, not only on solving real life problems, but also you have to succeed in the exams. Okay, so this is called the ordinary level physics review. It contains questions and solutions of from 4 next exams in physics from 2003 to 2019. You can also buy this book, and we have a very affordable price, a very low price compared to the price that you'll be buying these books in the local shop. Just to advise you, in order to minimize the shipping cost, because we know that you need all of these materials for you to succeed in physics. You can order this package, and we have a special discount. Just to go to the descriptions. The descriptions, just click the buttons, click there, show more, and then we'll see the link that will send you into too much details of these materials. So that's the end of session 3, the parameters of wave. I enjoyed myself. How about you? I don't know about you, but for myself, I've been happy, I've been enjoying, I've been getting so many revelations, and my understanding was actually growing when I was teaching you, from the beginnings of the session to the end of the session. I've never taught any students by using this approach or this style. I've never taught wave to other students by using the styles and the arrangement and the contents and the descriptions and the methods and the teaching aids that I used in this session. I'm not just boasting this, but really I want to tell you that God is at work. Because God is at work, nothing is impossible. What I've prepared before these sessions is less than what I spoke and what I taught. So even myself was getting revelations when I was teaching you. So thank you very much. I thank God first of all, who have created me in His own image and likeness. And even yourself, you have an image, you've been created in the image and likeness of God, regardless whether you know or you don't know, but we are telling you, in case you know, just we are proving your face. So I thank you very much, and I thank God for you who joined me from the beginnings of these sessions to the end. I invite you, join me in session 4, when now I will teach you about the wave equation. So the wave equations, we'll do having some examples, we'll be doing some computations, and we'll enjoy these wave parameters, because it will be next after the wave parameters. I invite you to join me in session 5, when I'll teach you about types of waves: mechanical waves, electromagnetic waves, transverse waves, waves, longitudinal waves. So we'll discuss all of those stuff to build up this concept in your mind. So remember to register permanently in this program. Remember to share these information to every Form 4 student in Tanzania. He or she can access this content free at any time and anywhere. Okay? So make sure that you share with them these contents so that they can benefit from now onwards in order for them to stay focused and the actual to pursue God's purpose that needs the knowledge in physics, chemistry, and basic mathematics. So I don't want to waste much of your time. Thank you very much for watching me. Thank you very much for learning physics with me, Physics Form 4. I invite you. I believe that you won't be alone, so you invite others. And also I ask you that to follow the instructions that I've given to you in order to prosper. This is Olenjolai from Tanzania. I love so much my country. How about you? So see you in the next session. May God bless you and keep you until we meet.